In this video, I will be discussing the importance of partial pressure in diffusion of gases. But first, there are a couple of items I must define. Pressure is the force that gas molecules exert on the surfaces with which they are in contact with. Partial pressure is the amount of pressure each gas contributes to the total pressure. And total pressure is the sum of all the partial pressures of all the gases in a mixture. So as you can see in this picture, oxygen has a partial pressure of 159, nitrogen has a partial pressure of 593, and when combined in a mixture, oxygen and nitrogen have a total pressure of 752. Partial pressure is extremely important in predicting the movement of gases. These gases move by diffusion. Diffusion is driven by a concentration gradient. So a gas will move from an area of higher partial pressure to an area of lower partial pressure until partial pressure in the two regions reach equilibrium. The greater the partial pressure difference, the more rapid the movement of gases. The greater the partial pressure of a gas, the more of that gas will dissolve in a liquid, such as blood, as the gas moves towards equilibrium. So why is all of this important? Simply put, this mechanism is important for human survival. Energy is not required to move oxygen or carbon dioxide across membranes. Instead, the difference in partial pressure between two areas is what allows them to diffuse. So for example, the partial pressure of oxygen is high in the alveoli and low in the blood of the pulmonary capillaries. This results in oxygen diffusing from the alveoli into the blood. Meanwhile, the partial pressure of carbon dioxide is high in the pulmonary capillaries and low in the alveoli. This results in carbon dioxide diffusing from the blood into the alveoli. So it is through this mechanism that blood is oxygenated and carbon dioxide is removed from the body.